Hey everyone! Today, we're diving into a critical component of container orchestration, the Cgroup driver in Kubernetes. Understanding the Cgroup driver is essential, especially if you've faced performance or resource issues in a production cluster. So let's get into it. Imagine this: you're running a production Kubernetes cluster for a high-demand web application, and one day, some of your pods start randomly crashing or experience performance issues. The culprit? It could be related to your Cgroup driver. Let's start with the basics. A Cgroup, or control group, is a Linux kernel feature that helps limit, monitor, and isolate resource usage for processes. In Kubernetes, a Cgroup driver is responsible for managing these resource limits at the container level, ensuring each pod uses only its allocated CPU, memory, and disk resources. Two common Cgroup drivers are Cgroupfs and systemd. The Cgroupfs driver uses the native Linux Cgroup file system, while systemd integrates with the systemd init system. The choice of Cgroup driver directly impacts how Kubernetes interacts with system resources. Now, let's look at a real-life example. Imagine your Kubernetes nodes run on an Ubuntu-based production cluster where systemd is the default init system. But let's say the Kubernetes setup is using Cgroupfs as the Cgroup driver. This mismatch between systemd and Cgroupfs can lead to performance issues, especially when resource-intensive applications are running. For example, you might see issues where certain pods use too much CPU, starving other applications. Or, in worst-case scenarios, containers may crash because they're not getting the memory or CPU they need due to the driver's limitations in managing resources effectively across the systemd boundary. One of the most common issues arises from a Cgroup driver mismatch. Kubernetes expects the Cgroup driver to match the node's init system. If you're running systemd on the node and the Cgroupfs driver with Kubernetes, there's a high chance of performance degradation, high CPU load, and memory leaks. Another issue you might encounter is inconsistent resource limits. You might notice that CPU or memory limits set in the pod's configuration aren't being enforced properly. This often happens due to mismatches or configuration drift over time, causing certain nodes to behave inconsistently. To avoid these issues, the best practice is to match the Cgroup driver to the init system used on the nodes. For example, if your nodes use systemd, configure Kubernetes to use the systemd Cgroup driver by setting it in the kubelet configuration file. This alignment helps avoid unexpected resource conflicts and improves system stability. Another good tip is to monitor your nodes. Tools like Prometheus can help track CPU and memory usage, allowing you to detect patterns that could indicate Cgroup driver-related issues. Additionally, testing any changes to the Cgroup driver or resource configurations in a staging environment first is critical for production stability. And that's a quick overview of the Cgroup driver, common issues, and best practices for production environments. Having a compatible setup with the right Cgroup driver can make a significant difference in performance. Thanks for watching, and don't forget to subscribe for more Kubernetes tips.